Optic is a ray tracing program that allows for AI agent authored scene creation and offers an editable layer for created scenes. It creates and outputs rendered artifacts through a connected compute system hosted by my VPS. Here, I give an AI agent a very simple message of a scene I want to create. It then works through said message and comes out with a preview image. From there, I can take this existing scene and ask for modifications. My AI agent understands a huge layer of edits, including materials, movement through the scene, and is building towards a complete editable layer for all of my scene work. When we open our pre-created scene in our actual editor, we see that there's no actual light source or camera movement. So I do some editing, I add in a camera start and end point, test it out with our preview system, so then I move on to the Bezier light path. This one I tweak over and over again, and then I set the output route and run the actual render. As expected, there were a few bugs in scene generation, so I went quickly to fix this and adapt our system to rebuild the scene in a slightly more sophisticated way. Once all aspects of the scene are good to go, I start the preview, check it, looks good, so then I start the actual render again. And this one is much more clean, so I do the final update of quality runs, and here we see the actual process running. And the system does not work with just primitives. We have a full complex scene representation for complex objects with a runtime mesh asset object with a top-level TLAS, BLAS system, optimized BVH. I currently have caustics established as both surface deposition and volume, and I'm currently working on a replacement photon mapping lane to eventually replace that. The views of our STL objects can be represented both as wireform and solid representations of their mesh and also their material if you want to check what color all the scene objects are. Here's an example of scene iteration. It started with a blank colored scene. I added materials, aspects, and colors, and then changed the camera orientation, and finally got to a quality render that I could output and knowingly enjoy the final output. I've also built a full STL import layer, so any STL object I download from the web, I can import into my scenes. Here's a recent recording of a transparent skull that I did. And with scope, I can zoom into certain aspects, run through the frames, inspect certain areas, and just allow for great visualization of my outputted frames. Here is my visualizer website to see rendered artifacts, but it does allow download, and you can also go through both MP4 and frame outputs in all of my recent runs. All of these are done headlessly through my system. This is a test of water visual that my agents worked on a while back in order to test and prove the water transmission of light. And here's a test of VF3D light deposition, so that light actually hits atmospheric mist in the scene. And here's just a large amount of all of our various runs that my agents have been able to create and curate over the last few weeks. And that's a wrap on my Optic program. So here's a fun little view of it actively rendering. Look at it go.